In this question we have a problem to find out equation of a line which is tangent to a point on the curve 4x cube equal 27y square, and the same line which is normal to other point. So we have a rough figure like this. Tangent at one point is becoming normal at other point. So here we are taking P point and Q point. Tangent drawn at point P of this curve is a normal for this curve at some other point Q. So first of all we can rewrite this as x by 3 whole cube equal y by 2 whole square. If we write capital X cube equal to capital Y square, then we can take a parametric point like this, xy equal t square and t cube. Any point in this form will always satisfy this curve. So we can take x by 3 y by 2 as t square t cube. So any point on the given curve number 1, any point on 1 can be in the form of 3t square and 2t cube. So we can take P point as 3t1 square and 2t1 cube, and Q point as 3t2 square and 2t2 cube. Now we have to find out equation of this line. So we need slope of tangent at P and slope of normal at Q. So by given curve number 1 we have 12x square equal to 27 into 2 y dash. So y dash equal to 12x square upon 2 into 27 y at some arbitrary point r. At r point y dash equal to t. If we put these values in this, we have y dash equal to t. So equation of tangent at P point can be written as y minus 2t1 cube equal to t1 x minus 3t1 square. This is the equation of tangent at P. If we observe here, we can write slope of tangent at P point equal to slope of normal at Q point equal to slope of line segment PQ. Here we are calculating slope of this line by 3 methods. First, derivative of the curve at this point P, and slope of normal at Q, and we are calculating also slope of line PQ by 2-point form. So slope of tangent at P point can be written as T1, as we have y dash equal to T here, and slope of normal at point Q can be written as minus 1 upon T2, and slope of PQ line segment can be written as 2 T1 cube minus T2 cube upon 3 T1 square minus T2 square. So we have 2 by 3 T1 square plus T2 square plus T1 T2 upon T1 plus T2, as we know that T1 cannot be equal to T2. Now we have T1 equal minus 1 upon T2, So by first two relation, by first two relations, we have T1 T2 equal minus 1, and by first and third relation, we have 3 T1 square plus T1 T2 equal to 2 T1 square plus T2 square plus T1 T2. If we use T1 T2 equal negative 1, we will have 3 T1 square plus minus 1 2 T1 square plus 1 upon T1 square and minus 1. If we solve this, we will have T1 square equal to two values. One is negative 1 and other one is 2. We can see that T1 square cannot be equated to negative 1. So T1 square equal to 2. Therefore T1 gives us two values plus minus root 2. If we put this value of T1 in given equation in the equation of tangent, which is L, so by line L we have two different results which are y equal to 2 root 2 x, y equal to root 2x minus 2 root 2, and y equal to minus root 2x plus 2 root 2. If we use this value of T1 in equation L, we have two different values of line L. So what we have done, I will summarize once more. We have this curve, and if we draw tangent at a particular point P, then it will become normal to some other point. So we have taken an arbitrary point R on this curve which always satisfies this curve. This is a arbitrary point in parametric form on the curve 1. We have taken P point as this and Q point as this. Now we have calculated slope of tangent P equal to slope of normal at Q and slope of line segment PQ. We have calculated slope of this line in three different methods, namely this and this. And finally, on calculating, we are having value of T1 as plus minus root 2, and if we use this value in the L equation, we have two different tangents which are the required answers.